I think we're 1 to 3 years away from having a chemical that actually is potent enough to reverse aging. There's a lot of publications out saying that exercise lengthens telomeres, meditation lengthens telomeres, certain things in your diet lengthen telomeres, but none of that's true. We're never going to make a major dent on aging. We're never going to get anybody to live healthy longer than 125 years unless we solve the telomere shortening problem. Gene therapy is the only thing on the planet right now that in our hands has been able to produce enough telomerase to actually reverse aging. I've literally had 20 different ultra high net worth individuals in my conference room where I'm sitting right now, and I don't want to mention names, but you know them all. They typically will want 80% of the company. They also didn't want to invest their own money. They wanted to take out a loan, and they wanted me to do something to focus on quick return on investments so that I could make the loan payments. So it's got to be the unknown ultra high net worth individuals. They're the ones that have to cure cancer, cure aging, cure heart disease, cure Alzheimer's, because everybody else that has money is only interested in making more money for themselves. I'm obsessed with not missing out. I want to be there for all the great things that happen in the future, and that's why I'm obsessed with curing my own aging.
Welcome, everybody, to the Unreasonable Health podcast. I have one incredible guest today that I'm excited to introduce everyone to. And this individual is the founder and CEO of Sierra Sciences, a company focused on finding ways to extend human lifespan and health span. It's Dr. Bill Andrews. He's been featured in Popular Science, the Today Show, Doctors TV show, and a numerous number of documentaries on the topic of life extension. So this fits really well into the Unreasonable Health podcast. So excited to have him on. A little bit more about Bill. He co-stars in a recent documentary with Dr. Aubrey de Grey, the documentary The Immortalists. That was on the top 10 list to receive an Oscar in 2014. He's also featured in a documentary called Longevity Hackers. And this just got released in December of 2024. So really cool documentaries. You guys should check them out if you haven't already. And then Bill received his PhD in molecular and population genetics in 1981. And what population genetics is, it studies the why and the how of evolution as opposed to just the what and the when, like most evolutionary biologists focus on. So, and then did a lot of work in molecular genetics. And this is where the study on how to control our own evolution. So super fascinating stuff. I'm excited to dive in. So some of the additional research and things that Dr. Bill's dove into include cancer, heart disease, and anything related to multiple organ and tissue decline and failure. So aging is just an accumulation of all the different ways we've evolved to eliminate the longer lived. Eliminating the longer lived increases our species' genetic diversity, which increases our species' ability to survive rapidly changing environments. It also explains why we have never evolved a way not to age, never will, unless we do it ourselves. And I love that. So we're putting the power back into the people's hands. So yeah, welcome to the show, Dr. Bill Andrews. Welcome.
Well, thank you. Welcome to be on.
Well, so I'm just fascinated by all the different things that you're working on. We've had a little bit of a conversation around some of the things that we do at EastWest, but I think we're very much aligned in what we focus on as far as life extension. But I'm curious, what would you say the what, why, how, and how not of aging? What is that?
Well, it's just something that a lot of people misunderstand. A lot of scientists actually misunderstand it. I tend to not just look at one aspect of aging. I've been studying aging my whole life. It's ever since my father convinced me to go into the field when I was 10 years old. I've been obsessed with it. I started anti-aging clubs and stuff like that in high school and college. And I've been just very fascinated with the whole subject because personally, I don't want to age myself. And I'm still aging because I haven't figured out exactly what to do. And one of the things I hope we have time to discuss why we haven't been able to figure out what to do yet. But one thing that I've really gotten to understand, especially getting my PhD in population genetics and molecular genetics, was aging has always been inevitable and unavoidable in nature. I mean, it's not something that evolved. It's something that nothing ever evolved not to let us age. Okay, it's because there's no evolutionary advantage to living longer than it takes to raise your young. And I say that because a lot of people think that evolution is something that occurs for the benefit of the individual, but it's not. Evolution is something that occurs as a benefit to the species. The individuals are not necessarily the benefit to the species. So I guess it comes down to ever since sexual reproduction, and which evolved about 2 billion years ago, we have, our species and other species have gone down the path that sexual reproduction really adds variety or diversity to the species. And that as soon as you have passed or shuffled your genes to make a new child, you're no longer a benefit to the survival of the species. The shuffling of the genes to make a child has increased the diversity in the species. Therefore, the species has a better chance of surviving a rapidly changing environment. At least some members of the species have a higher chance of surviving a rapidly changing environment. So as a result, any, let's say, mutation or new gene variant that occurs that affects only people after they've raised their young, those are going to be very sustainable in the population. Okay, and these are cancer, heart disease, Alzheimer's, anything related to those kind of diseases, they are just going to be sustained. You're going to pass them on to your children before you ever know you have the symptoms. Okay, as a result, there's no selection against those different traits. So as a result, those kind of traits have just been accumulating over and over again. And now we're filled with probably 1,000 different mutations or gene variants in our genome that essentially eliminate the longer lived. Okay, so and I call longer lived as anybody who has lived long enough to raise their young. Okay, so
that's the definition on longer lived, because I was curious about that in your bio. So the longer lived is if you exceed your raising your young, essentially.
And still a question of when have you raised your young? I mean, it's like how important are grandparents? If grandparents are extremely important to raising young, then you haven't raised your young until you're great-grandfather, great-grandparent. But it's still, the bottom line is that there is a limit, and there's a point at which you become unbeneficial to the survival of the species because you've already shuffled your genes, and shuffling your genes even more does not contribute as much as originally shuffling your genes. And so eliminating the longer lived turns out to be a benefit to the species because it gives the opportunity of the offspring to interbreed more than the parents rebreed. And so when the offspring interbreed, shuffling is even more complete and more, especially with the fact that new mutations are always being entered into the population. Getting these mutations shuffled among as many people in the population as possible is done better by letting the offspring interbreed and the parents rebreed. So,
Interesting.
so that's not a reason why we evolved aging. That's a reason why we never evolved a way not to age. Okay, because there's been no advantage to it. But the aging has just been involved because of the accumulation of gene variants that exist in our body that are, let's say, toxic to the longer lived, but not the shorter lived. Okay, so are very, very infrequent. Yes, there are children that get cancer, but nowhere near the rate that older people get cancer. So, but cancer is one of those things that has accumulated because once you raise your young, there's no selection against evolution getting rid of cancer. Okay, just in a whole lot of diseases. But as I said, as a result, aging is inevitable and unavoidable in nature. Now,
Yeah.
humans are a little different because humans are the only first species that are smart enough to actually do something about evolution or to control their own evolution. And that's one of the things that I'm trying to do. And interrupt me anytime you have a question.
I'm curious. Well, I'm really curious about kind of how you got here. So you mentioned when you were really young, your dad kind of pointed you in this direction. So tell me about that relationship. What made your dad point you in that direction?
I didn't know this until I was 10, but my father had always been interested in curing aging. My father was a television producer, and he was actually a top television producer. His name is Ralph Andrews. He produced probably 50% of all the game shows that occurred back in the 1960s, 50s and 60s and things like that. Most notably, You Don't Say, By the Numbers, It Takes Two, Celebrity Sweepstakes,
Oh, wow.
Lie Detector. I mean, I grew up with movie stars in my house all the time because they would come to spend a whole week doing one show after another. They get aired once a week or once a day, but they would do like 7 shows a day filming. And so the movie stars would stay in my house. That's actually, I'm going to be mentioning Betty White probably sometime in this thing. And that's how I got to know Betty White really well. Betty White and my family were really good friends. I taught her how to water ski. I taught her husband how to water ski. It's like,
Hey, there's not a lot of people. I guess no one other than you can say they taught Betty White how to water ski. That's incredible.
you know, I there were so many movie stars. I can't remember if I actually taught Betty White how to water ski. There was also the Wild Wild West cast, the Hogan's Heroes cast,
Oh, wow.
Bonanza cast. They all spent like several days at my house, and my job, my father told me, was always to take them out in the boat. And we lived on Lake Arrowhead, and take them out on the boat and give them tours and teach them how to water ski. And so that was my job all the time.
That sounds like a fun one. That's great.
No,
I
it
love
was
going around on the boat, and it's fun taking new people and exploring. So that's fun.
I had a fun time when I was young, and largely due to my great parents. I had wonderful parents. But when I was like 10 years old, the teachers of my elementary school class sent me home with a note pinned to my shirt. And the note said to my parents, "Your child is very, very interested in science and medicine. You should nurture this." And so for Christmas, I had gotten this like 8-inch reflector telescope. When I was 10 years old, no kid gets a telescope, but I insisted on a really great telescope. And I was out on the front lawn every night, finding every planet and the moons of the planets and things like that.
Awesome.
And my father came out to me one night and said, "Bill, since you're so interested in science and medicine, when you grow up, you should become a doctor and find the cure for aging." And then he said, "I don't know why nobody's done that yet." He thought for some reason it was going to be a disease just easily cured, just like anything else. And so I did. I grew up thinking aging was a disease and it's got to be cured. Just because we all have it doesn't make it not a disease. So I ended up getting very obsessed with that idea. And for the rest of my life, I've been studying aging and just trying to logically think about it, make it a common sense thing. And the problem that I had was all the theories on aging made no sense to me, because I always say all the twos and twos have to add up. And yes, we can say this and that about aging, but it doesn't explain everything. So there had to be something more going on. And by the time I was in high school, and I was already developing anti-aging clubs, and we were having all these discussions, and we had learned about the Hayflick limit. Leonard Hayflick had published the Hayflick limit in 1961. Most people didn't believe it at the time, but when I heard about it, I thought, oh my God, I believe it. I think this is a really, really good explanation of why we age. But still, the question was, why is there? So Leonard Hayflick discovered that human cells can only divide a certain number of times. Okay, and then they stopped dividing. Everybody thought that can't be wrong. Everybody thought human cells can divide in a petri dish, can divide forever and ever and ever and ever. But now everybody knows that it's absolutely true, that human cells can only divide a limited number of times, and they grow exponentially at a linear rate on a log scale, and then all of a sudden drop and just don't grow anymore. That drop is called the Hayflick limit. Leonard Hayflick had no explanation for the Hayflick limit. But I spent a whole years trying to figure out what kind of mechanism could exist inside of a human cell that would explain the Hayflick limit. And, I was one day playing pool, and I was in Palm Springs, and I shot a ball into the pocket and took my cue stick and moved a wooden thing from one side of the long string to the other to mark that I had knocked the ball in. And I thought, oh my God, is there a way that cells could have something like that going on? And that was my first idea. I started working on, is there a biological mechanism to keep track of how many times a cell has divided and how many times it has left, the same way we keep score in pool. But I kind of moved away from that because it didn't work. It then led to the idea of, could we have something inside of our cells that was like ride tickets at an amusement park? Your mother gives you a bunch of tickets. Let's say you got 20 tickets, you go ride a ride, you only have 19 tickets left. Well, you know how many more rides you have, and you know how many rides you've done. Could there be something inside the cell that was like ride tickets at an amusement park? And again, I just could not really figure anything out. And then it wasn't until the early 1990s that I was attending a conference in Lake Tahoe, in Tahoe City, at the place called the Grand Labakan. I forget the name of the conference, but I actually started a new company with Mike Rose and a guy named Sabir Pavir, I can't remember now. And we were going to culture mice to try to culture mice in a way that we'd select for longer lived mice, and then go look at their genes and find out what was selected for. This was something that Mike Rose had done a lot with fruit flies. And so we were going to try to do this together with that. At that same conference, I'm going to get to the point eventually. At that same conference, my father was there too, because he was still very interested in anti-aging and curing aging. By the way, the term curing aging was invented by him. Okay, ever since I started getting into the limelight and started using the curing aging term, everybody said, you can't cure aging, it's not a disease. And so now it's caught on a lot. But my father said cure aging, so I use cure aging. My father thought it was a disease, so I thought it was a disease. But he went to the conference because he was making a documentary on aging. And he wanted to meet all the great scientists that were studying the field, and he wanted me to introduce them to them. So I did that. But getting back to Mike Rose and Severe Pavir, we started this company. We called it Methuselah Research. We stayed up all night planning it. I was going to be the president. Mike was going to be an advisor. Something, I can't remember all the details, but the next morning at that same conference, I heard Dr. Calvin Harley talk about telomere biology and the fact that telomeres get shorter as you age. And I'm sitting in the audience and I'm saying, oh my God, here's those ride tickets. The ride tickets that I'm using
They are
at the tips of our chromosomes. And so before he even could get off stage, I was at the bottom of the podium, at the bottom of the stairs of the podium, saying, asking, has anybody figured out how to prevent telomere shortening, how to lengthen telomeres? And he says, no, we've been working on it for many, many years, collaborating with labs all over the world, and nobody has figured it out yet. And I said, well, let me come and work for you, and I will have it figured out in 3 months. And it was actually the shortest job interview ever because he offered me the job on the spot, because I'd already been one of the key inventors of human growth hormone, tissue plasminogen activator, osteoinductive factor, erythropoietin, beta seron, many, many blockbusters in the biotech field. The enzyme renin for converting milk to cheese, I invented that too, so it wasn't all medical. But he knew of my track record, and so he said, okay, we're going to give you a shot. Come on, let's do this. And so 3 months and 17 days later, my team ended up discovering the enzyme telomerase. I say team because nobody ever does anything on their own, but they put me in charge of 3/4 of the company at Geron Corporation. And I orchestrated a whole plan of trying 5 different things at the same time to try to discover telomerase. And we did. We discovered it in 3 months and 17 days. And we did it by recognizing the fact that our reproductive cells don't have telomere shortening. And if they did, our children would be born with shorter telomeres than we have, and their children were born with shorter telomeres than they have. So we would have been extinct as a species a long time ago for lack of DNA. So reproductive cells had to have some way of preventing telomere shortening. And we discovered the enzyme telomerase or human telomerase. Telomerase had already been discovered in Tetrahymena by Carol Greider and Elizabeth Blackburn. But at that time, they had not connected the dots to show that it had anything to do with aging. In the documentary Immortal, which I was also in, but almost won an Emmy, Immortal and Immortalist are 2 different documentaries. But they clearly said that all they thought was that this telomerase, or which they call telomere terminal transferase in Tetrahymena, a single cell organism called Tetrahymena, was just an interesting piece of biology. They never connected the dots to it actually being a way that telomere shortening causes aging or also increases the risk of cancer. And but later, when others like Calvin Harley and Richard Alsop published papers on the telomere hypothesis or telomere theory of aging, maybe they called it hypothesis, but I don't think they had anything to test at the time. Then it became clear to a lot of people that, hey, maybe this might be some role in aging. So Calvin Harley at Geron Corporation and Mike West, who was the founder of Geron, they found lots of universities, academic labs, to work with them to try to discover it. And that included Carol Greider's lab and Elizabeth Blackburn's lab. But they were unsuccessful because everybody was trying to find something that was similar to the Tetrahymena telomerase. And so when I got on board, that was the first thing I said, let's not focus on that. Let's not assume that it's identical. So we came up with a bunch of other protocols, and we ended up discovering it. And then went ahead and actually discovered the real components of telomerase in tetrahymena also. And that was published probably in the mid 1990s. But at the same time, so we discovered telomerase, but we also, at the same time, because I was already National Inventor of the Year for my cancer research. I had already done a lot of cancer drugs and put them in clinical studies and stuff like that. So one of the things that we were interested in doing was just to see, well, what would happen to cancer cells if we put the antisense of telomerase into cancer cells? And it ended up killing every cancer cell, okay, because it essentially accelerated their aging by using the antisense. So that's why I became National Inventor of the Year. So I said it was beforehand, but it was afterwards, because I'd already done a lot of cancer research, but I didn't get that award until after this study where we put the antisense of telomerase into cancer cells and showed that it killed all cancer cells. And we filed a patent on it, and National Inventor of the Year. And the other thing that happened was Geron Corporation decided that curing cancer had a quicker return on investment than curing aging. And I'll come back to that subject again later. And so they told us all to quit working on aging, focus on cancer. Well, me and a few others still worked on aging a little bit to find a nutraceutical that would induce telomerase. That's how TA65 came along. And then I put the telomerase gene into human cells in a petri dish and showed that they never reached the Hayflick limit. And so I presented that at a conference. And again, when I say it wasn't just me, it was a team. I was just a team leader. That was the director of molecular biology there. But a lot of it was my ideas and stuff like that, but to pursue these things. And we put the telomerase gene into normal somatic cells, fibroblast cells, and showed that they never reached the Hayflick limit. They suddenly went beyond the Hayflick limit, and they were perfectly healthy. They never turned into cancer cells. They actually just remained as young cells all the time. So I presented this data at a conference, at a meeting, a strategy meeting inside Geron Corporation. And after I got done, and a few people applauded at the thing, but the thing that really bothered me is that I got chastised for working on aging when I was supposed to be working on cancer. And so at that time, I walked across the room to my office and called up some potential investors, a CV company I know, and said, I'm looking for a new job. I want to start my own company to pursue aging. And so I left Geron shortly thereafter to start Sierra Sciences to continue Geron's first mission. Geron is short for gerontology. So the first mission was to cure aging. Now all of a sudden they want to cure cancer. Instead, I'm very interested in cancer, but I believe that the main cure of cancer is to cure aging. So I started Sierra Sciences to focus on curing aging. And I'm not going to say that I'm a telomere biologist. I'm an anti-aging biologist. And right now, telomeres just struck me as the main thing that I wanted to work on, because it seemed main reason I wanted to work on it was because it was, as I had figured out, the one and only thing in all of the theories of aging that we actually have to control or will never ever succeed in anything else. I didn't want to say that telomeres were the only cause of aging, but it's the only thing that we have to do, because no matter what else we do to cure aging, aging will never be cured unless we also solve the telomere shortening problem. So I focused Sierra Sciences from the very get-go on finding a way to lengthen telomeres. And we've pursued pharmaceuticals, nutraceuticals, gene therapies, and a lot of the studies that came out showing that we could reverse aging with telomerase was gene therapy. And the classic study by Dr. Rhonda Pennell at Harvard that was interviewed on the Diane Sawyer. There's a YouTube video that you can find of Diane Sawyer interviewing Rhonda Pennell, where he used gene therapy to actually reverse aging in mice in every imaginable way. And it's the only thing that's ever done that. A lot of people talk about they've reversed aging, but they've only reversed biomarkers of aging. They haven't actually reversed aging. And that's where Betty White comes in. I always show pictures in conferences of Betty White at 25 and 95. And I just say, does anybody here not know which photo of Betty White was taken first? And usually gets a laugh, but the point is that you don't need biomarkers to measure aging. And nobody goes to their doctor and says, I wish somebody would reverse my aging. And all they needed to know was that their telomeres got longer, or their DNA methylation patterns changed, or their IgG glycosylation patterns changed. They wanted to pass what's called the Betty White test. They wanted to go from 95 to 25. I mean, you could change the hair color, you could get rid of the wrinkles, and Betty White at 95 would still look older than that picture of her at 25. But I always say you have to look, feel, and behave 25 again. And if you don't, you have not cured aging, okay? No matter what the biomarkers say. When you reverse biomarkers, all you've done is reverse the biomarkers. They do correlate with aging, but reversing them doesn't correlate with reversing aging. They only correlate with the reversal of the biomarker. So we have to pass what I call the Betty White test. And I almost quit doing that test when she passed away, but I've gotten back to it.
And is there a test that you like to use for telomeres?
Yes, well, we have our own in-house telomere test, but I'm one of the inventors of almost every telomere length measurement protocol there is. And none of them, in my opinion, work very well. And it's because they're very difficult to do. And there's, nobody really knows yet which telomere is important. By measuring all the telomeres, you get a lot of noise, and we can't focus yet on what the actual key telomere is that we should be measuring. I actually say that DNA methylation and IgG glycosylation work better for measuring aging than telomeres do. But we use protocols here in Sierra Sciences that are far, far better than anything that's commercially available. They're just too expensive. And Dr. Shang Li recently published a paper identical to the protocol that we've been using here for 10 plus years. And because we never published it, or we're not into publishing or anything like that. But we're grateful that Shang Li published it, and hopefully somebody will make it commercially available, find a way to make it cheap enough to be commercially available. But it has to do with actually sequencing the telomeres. And not only do you get the length, you know what chromosome it came from, and you also know if there's any aberrant telomere sequences buried in the middle of the telomeres that are passed on from generation to generation that might cause health problems. So it's a plus, but that essentially costs $1,000 to do a measurement.
Wow.
There's something else I wanted to add.
I'm curious. You mentioned the pivot to kind of cancer, and I know you've talked a little bit openly on this, but what would you see like problems with the funding strategies that kind of explain why cancer, aging, and some of those things aren't quote unquote cured yet? I'm
what
stance there.
I want to say a lot about that. But let me just say one more thing about aging that I just forgot to say before, and I just thought of it. There are a lot of clocks that measure aging, okay? And they do a good job, and because of their correlation with aging. But nobody has identified the mechanism that causes these clocks to tick, okay? And the only one that has been shown completely how they tick is telomeres. Telomere shortening, we totally understand the mechanism. We totally understand why aging causes telomere shortening, and therefore why telomere shortening is a good measure of it. And we know that reversing telomere shortening actually does reverse aging in human cells in a petri dish, human skin grown on the back of a mouse, and Rhonda Pinno's experiment with mice, and a few other experiments that have been done with mice, though mice don't really age by telomere shortening. Telomere biology and aging is extremely different than humans. I'm always saying the ideal animal to use instead of mice is pygmy marmosets, because they do age just like humans do, and they're very closely related to humans, and they're small enough to be able to do clinical studies cheaply with large numbers of animals. But the thing is that we do understand the mechanisms of how telomere biology affects aging, how lengthening telomeres can reverse aging, and how it does in the studies that I just showed you. And also how it actually controls the other clocks, okay? So the DNA methylation and the IgG glycosylation are really just measuring telomere length, okay? Because telomere length is the thing that's affecting the DNA methylation and the IgG glycosylation. And a lot of things like sirtuins and things like that, they go up and down. Their production, so as you get older, sirtuin goes down. Okay, certain portion goes down. But if you lengthen the telomeres, it goes back up. Okay, it's because telomeres work like enhancer sequences to regulate gene expression. And so the number one mechanism of epigenetic changes that occur in our cells as a result of aging comes from the epigenetic role that telomeres play in gene expression by acting like an enhancer. So they can turn genes on and off, or like a dimmer switch, just on and off, or somewhere in between on and off, just by the fact that when the telomeres get shorter and shorter and shorter, it's harder for the telomeres to reach as far as they could to reach the gene. The telomeres fold over and come in contact with the genes, act like enhancers to turn genes on and off. So again, I believe
what are you seeing, or kind of some of the best strategies there if someone's looking at extending their telomeres from your research and your standpoint?
Well, there really aren't any good products yet. We'll get back to that funding thing about cancer and aging. They come under the same category. There are, and I'm inventor or part inventor of every one of them, but I don't market things, so I'm not going to try to tell you why you should buy these, but there are lots of nutraceuticals and at least some pharmaceuticals on the market now that I invented that do induce low levels of telomerase, way better than epitalon, which doesn't express any telomerase, and TA65 was one of the first ones that we discovered back when I was still at Geron Corporation. So I'm one of the co-inventors of TA65, but it's weaker than I think what we need to find. And so I'm continuing research to find more and more potent telomerase inducers. And at the place where we are now, our strongest telomerase inducer, which is a chemical called C0314818, because it was the 314,818th chemical we tested, that produces 16% as much telomerase as what we think we need to actually stop aging. So we think we're 1 to 3 years away from having a chemical using our high throughput drug screening where we can test up to like 4,000 chemicals a day. I think we're 1 to 3 years away from having a chemical that actually is potent enough to reverse aging. And the other ones, all they're going to do is
The concept there would be is it's a powerful enough telomere enzyme where it's like lengthening the telomeres more than the difference of aging that's creating. Is that the concept there?
yeah, well, telomere shortening and lengthening are going on at the same time. I call it a tug of war. So the shortening is caused by two things. One is the end replication problem, which we can't really do anything about. And the other thing is all the different things that accelerate telomere shortening, like oxidative stress, inflammation, things like that. And you can slow down the accelerated telomere shortening, but you can't slow down the end replication problem type telomere shortening. I call that basal level telomere shortening. The only way you can is by reducing telomerase. So it's like a tug of war where we have people on one side of the tug of war pulling to shorten telomeres, and the other side of the tug of war is lengthening telomeres. But in all of our normal cells, we only have people on the side pulling to shorten. So our telomeres just keep getting shorter and shorter and shorter and shorter, like a clock. And then by giving yourself a nutraceutical or pharmaceutical that induces telomerase, you then add people to the other side of the tug of war to start lengthening. But we haven't reached the point where we have more people lengthening than shortening. So the tug of war is still being lost, but at a slower rate. That's why nobody taking TS65 or any of the other theories, nutraceuticals, pharmaceuticals, or theories on telomere biology have actually caused anyone to pass the Betty-White test yet. Nobody has ever passed the Betty-White test. And that's what we really have to do. Otherwise, we haven't really cured aging. I'd mentioned other things besides supplements and nutraceuticals. There's a lot of publications out saying that exercise lengthens telomeres, meditation lengthens telomeres, certain things in your diet lengthen telomeres. There's now studies showing that telomeres actually jump from one cell to another, and that lengthens telomeres. But none of that's true. None of that actually works. I mean, DNA does jump from one cell to another. We saw that when I was still at Geron Corporation. We never thought it was worth publishing because you have cell A, you have cell B. The telomeres from cell A jump to cell B. Well, the telomeres in cell A get shorter and the telomeres in B get longer, but the average stays the same. So as a result, you're really not, somebody thought it was worth publishing that they can see telomeres jump from one cell to another, but there's no, and they're doing clinical studies on them now, is what I hear. But I'm really suspect that the clinical studies aren't going to result in anything except saying that some cells got longer telomeres.
Yeah, I think if you look at lifestyle though, like how I got working with Reagan and into EastWest is I was like 60 pounds heavier than I am now. I like chronic brain fog, a lot of things. And I would argue, 10 years ago, if you look at a picture of me then versus now, it's significantly different from just an age perspective. But I think lifestyle and finding the right things that are going to be good for your genetics and things. I guess my argument would be is it does seem like there is some age reversal there. And I'm not saying we got the cure for aging, but I've seen people that, if they dial in their weight loss, exercise, maybe get some support from nutrition. We use a lot of peptides for support, but it's crazy what the difference they look in 6 months to a year from when they initially started.
You're exactly right. Okay. I mean, there's nobody that does more lifestyle and diet and supplement things to slow down and reverse some of the effects of aging than I do. Okay. I am.
You got some great tools and strategies there.
Yeah, but it's not just telomere biology. Okay. There's so many things. Decreasing inflammation is the number one most important thing. I mean, I recommend people get ALCAT tests or MRT tests. They can Google them, ALCAT and MRT, to find out what foods cause them to induce inflammation. Everybody's different, so everybody gets different results. But you just got to stop eating the foods that cause you inflammation. That's something I do. Exercise, if you do it right, is something that can reduce inflammation. I mean, if you're somebody who occasionally runs every 2 weeks and competes in a marathon and does well, crossing the finish line, throwing up on your hands and knees, you're not doing yourself any favors, okay? But if you are a consistent runner, or in any endurance exercise, including kayaking and snow skiing and bicycling, if you do endurance exercise and keep it fun, and do it consistently, like every day, that's a great way to reduce inflammation. Okay, and I mean, I've done studies where I've gone to races that I was even running, and I've had people draw blood from runners before, during, and after the race, just to look at things like CRP data and stuff like that. And it, people that run every day and then keep it fun, they don't increase inflammation even when running 100 miles. Okay, as long as they keep it fun. And so I say, when it quits being fun, quit, save it for another day. But there's so many other things. Meditation is a way to reverse the effects of aging. But does it lengthen telomeres? No. Okay. So telomeres are only part of the puzzle. Okay. But there's a lot of things that people can do, and I could probably spend an hour talking about listing them all. But I believe that we're never going to make a major dent on aging. We're never going to get anybody to live healthy longer than 125 years unless we solve the telomere shortening problem. And personally, I want more time. My reason for wanting to cure my own aging is I don't want to miss out on all the great things that are going to happen in the future, like finding life in outer space and things like that. I just want to be there. So I'm upset. I'm not afraid of dying. I do a lot of dangerous things, foolhardy things that could kill me. And I used to hold the world speed record for barefoot water skiing. And people that used to compete with me died from falling at those speeds. And but it didn't discourage me at all.
So how fast would you go barefoot skiing? That's impressive. I didn't know that.
I broke the record at 74.93 miles per hour.
Ooh. Did you fall going that fast?
I fell one time going at 80 plus miles per hour when I was trying to break my own record. I have pictures here of me doing the fall. My body is just twisted into all kinds of pieces.
Oh man!
Actually, I fell because the rope broke. The rope from the boat broke.
Oh no!
So I didn't even know that I was falling. Okay, I just saw the pictures later on. But I was all, because the rope broke at the base of the boat, I was all wrapped up in the rope, still holding onto the handles. And emergency boat. It was in front of thousands of people. It was a grandstand on both sides of the Long Beach Marine Stadium. And they had to take a rescue boat out there. People had to jump in the water, cut the ropes off of me, drag me into the boat. I insisted on walking out of the boat because I had the wind knocked out of me, everything, but I didn't die. But people that had competed with me at shorter speeds, they did die, slower speeds. But
any big injuries from that, or?
Yeah, no, I was very stiff for several months, but I got right back into the sport and was still competing for a while afterwards. It's like, yeah, I wouldn't have done those kind of things. But yeah, that was, they said it was 80 miles per hour. Now, I still might hold the world speed record at 74.93 because the very next time I tried to break my own record at Oakland Marine Stadium, I ended up getting very bad injuries to the bottom of my feet from the speeds. And in that case, I did fall and survived again. But the American Water Ski Association then required that we had to wear booties, wetsuit booties is what started off. And so right after we started doing that, the speed record just went up into the 90s and the hundreds. And so all those are without using actual bare feet. They have booties on. And so I still might be the fastest person ever to go through
true barefoot.
Yeah, on bare feet. But long, you can edit all that out or whatever you want. But we got on a long tangent. But the thing is that I'm obsessed with not missing out. I want to be there for all the great things that happen in the future, and that's why I'm obsessed with curing my own aging. And that is my number one drive, curing my own aging. Okay, maybe this is a good time to get. Why is it taking so long? Why is cancer not cured? And there's so many things. So I give talks a lot at conferences, and I will actually start off with saying, I want to explain to you why cancer is not cured. There's several reasons. First, in the academic environment, professors can't do any research themselves. They all have teaching requirements. They're all they're spending their entire time writing grants. They have to publish papers because they can't get grants unless they publish papers, according to the publish or perish mentality. And so the people that do all the research in labs are newbie graduate students and postdocs, okay, that really have not had the years and years of experience to really do experiments right. And they don't also have the time for their supervisor to supervise them as much as they could. So the academic system is not a great system to find cures for cancer and heart disease and aging and Alzheimer's and things like that. And so when I was getting my PhD, I had learned that when I was getting my PhD. I decided there's no way I was going to go and stick with academia because I hated seeing my major professors all stuck in their offices, never doing any work except for writing grants and preparing lessons and grading tests and things like that. So I chose to go into industry instead. And so now I couldn't find, I wanted to go into industry in a lab that was actually working on aging, but I couldn't find anybody that made any sense, and all the twos and twos had to add up. Nobody accepted the idea that it had to be something like ride tickets at an amusement park. That's the only explanation. They all had these crazy ideas. Oxidative damage does not explain everything about aging. Inflammation does not explain everything about aging. So the ride tickets at an amusement park would. So I chose to go into industry and not do aging research at first, and just wait until something came up that would make sense, and then jump ship, which I did later on when I went to Geron Corporation. So for the first 10, 12 years of being in biotech, I was focused on cancer research, heart disease research, inflammation research. And now I forgot why we went down that road. What did you just ask me?
Well, it's so I think the question is why isn't what kind of funding going on, and why is cancer and aging not cured?
So what I learned was that so I learned this a long time ago, but I still got suckered into it anyway. Investors, sophisticated investors. That's how biotech is funded, by industry is funded by investors. Sophisticated investors, they're not interested. They're interested in the dream that the company provides, but they're not interested in that dream coming true. They're interested in capitalizing on the dream by making the company more valuable and then selling it for a profit. Okay, sophisticated investors are more focused on how can they turn their present wealth into bigger wealth. And so I've seen, this is one of the reasons that Geron Corporation moved away from aging and into cancer. okay, was because I spoke at the board meeting of all the investors, spoke on the cure. Excuse me, my dog started barking. If he does it again. Okay, so doesn't like having that cone on his head. Okay, uh, I gave a presentation to the board of directors, all the investors and stuff at Geron Corporation on how, in practically the same week, we had found a cure for aging and we had found a cure for cancer. And the chairman of the board of directors stood up and said, okay, we can't focus on both. We can't do both. Which one's going to bring us quickest return on investment? And they all decided cancer would be first to bring the quickest return on investment, which Geron short for gerontology almost seemed like they were just betraying their whole principles. But that's what Geron did. They switched from turning away from curing aging to curing cancer. That's why I left Geron and went to work with Sierra Sciences to found and create and start Sierra Sciences. And so this was the first close at hand experience that I had with that. But I still went and started Sierra Sciences by finding investors in hopes that I could find investors that were truly interested in curing aging. And I did at the very beginning. I found my first investors were very, very interested in that, but they had to raise more money by having me give more presentations. My company's name used to be Yonder Technologies. But one time I gave a presentation on behalf of the investors at an organization called the Sierra Angels in Lake Tahoe.
Yeah.
I was in line. There was like 5 people ahead of me, each giving their 10-minute talk, then getting off stage. And nobody came forward. Maybe one person came forward to one person and said, let's meet back and talk about investing. I got on stage and I talked for 10 minutes. And every single person in that room stood up, got in line to invest. And I made a ton of money that day. And we had a follow-up meeting the next day. And one of the things that was decided that we had to change the name of the company because nobody wanted their friends to know that they invested in something called anti-aging. And Yonder Technologies was already known as a company focusing on curing aging. And so I just said, well, since you're
there's like a negative connotation with it in the investment.
Back then there was. This is before Aubrey de Grey. Aubrey de Grey changed the whole premise of everything about aging. But people thought anybody investing in anti-aging must be completely off their rocker back then. Okay, this is the late 90s, early 2000s.
Okay.
And so I said, since you're the Sierra Angels and you're now the major investors in Sierra Sciences, let's call it, or in Yonder Technologies, let's call it Sierra Sciences. And that stuck. So we're now called Sierra Sciences. But then later, right away, they started having me do other things. They took over my scientific strategy meetings, telling all the scientists to work on other things, not trying to induce telomerase, because they wanted quick return on investments. So we did, and we spent like many, many years just doing what they wanted us to do, with the idea that eventually we're going to get back to trying to induce telomerase to lengthen telomeres. And we were very successful at getting everything they wanted done, so successful that they had a board meeting and voted to sell the company, because now they had added value to the company. Let's sell it and sell all the IP too, which means that I couldn't continue my research, especially since I had a non-compete clause in my contract. So I was pretty devastated then, but at least the original investors that were really interested in cure for aging, they orchestrated, and a new one that came along, a guy named Christopher Chase from New Zealand. They all got together and orchestrated a complete takeover of the company in a way that made all the other 50 plus investors happy, but it also turned all the ownership over to them that they then turned over to me. Okay. So I became 100% owner of Sierra Sciences. And now I won't accept traditional investors anymore, sophisticated investors, because all they're interested in is adding value. They're not interested. They invest in the dream, but not the dream coming true. And I want the dream to come true. Now, it's been a struggle ever since because it's a little harder to raise funding without investors. So I started doing what's called go-to-market partnerships. We had made a lot of discoveries while doing our research that we just put on the shelf because they didn't cure aging. But we thought, well, now that I don't have investors and we need to find a source of funding to fund our research, why not find people that might want to market some of these discoveries? Even though they don't cure aging, they'll slow down aging. Okay, and so we license our nutraceuticals to a company called Isagenix. We license our pharmaceuticals to a company called One Truth 818 in New Zealand, and we did a few other licenses, but those were the two main ones, and the two that exist still. Or no, so Isagenix, the founder of Isagenix ended up passing away, and so that ended up terminating that agreement. But a new company, which actually, let me announce that a new company, Touchstone Essentials, their website is thegoodinside.com, www.thegoodinside.com, all one word. They're going to be launching a nutraceutical product that we invented here that induces telomerase expression in probably March of 2025. So it's coming up. It's the product's already been developed. It's already, bottles are being made. Bottles are being filled right now. And that'll be a launch by Touchstone Essentials. And that'll be, without a doubt, the most potent nutraceutical telomerase inducer on the planet. And I sound like a marketer now, but I'm just talking about the science. It is, I've compared it to everything. It is way more potent than anything else. The only
It's like liquid capsules. What?
It'll be capsules. It'll be capsules. I don't know how much it'll cost or anything like that. I mentioned Christian Chase's name before. He was one of the investors. He runs a company in New Zealand that actually is in product development. So he's taken it over, and he's working closely with Touchstone to develop the product, and it's made they've made a lot of progress, and so much so that they're now expecting late March to be the launch date, and that will bring me lots of royalties because I'll get royalties from the product profits. That'll give me a lot of royalties that I would then use to fund the research. I mean, my investors, when I had all these investors, they were investing $2 million a month, okay? And because it was a better way of just putting a lot of money in the bank, that way they were just investing monthly. And this hopefully will bring us back to that stage, and then we can start really focusing on getting the more potent stuff that will actually reverse aging. The most potent stuff we have right now is one, the pharmaceutical, which C0314818, that is sold by a company called One Truth 818, that produces 16% as much telomerase as is needed to stop aging, but at least it slows it down. And then the other thing is gene therapy. Gene therapy is the only thing on the planet right now that in our hands has been able to produce enough telomerase to actually reverse aging. And as I said, we've done that in human cells in a petri dish, human skin grown on the back of a mouse, and Rhonda Pinto did it with.
And is the concept there an injectable, or what's the
gene therapy would have to be injected. It would be injected it would be injected intravascularly to get to the rest of the body, and intrathecally to get to the brain. But I strongly believe that a major cause of Alzheimer's is telomere shortening. especially in the oligodendrocytes that are producing the myelin that protect the neurons. So I believe that, and in Rhonda Pinno's experiment, when he treated mice, he actually saw brain sizes get bigger and mice start to remember things that they had forgotten. And so it begged the question, is Alzheimer's and other forms of dementia the loss of memory or just the loss of access to the memory? And right now I'm betting that it's loss of access to the memory because of telomere shortening. But I also believe there's a whole bunch of other things. I'm working with a company called Synap. I don't know how public this is, but they're working on a treatment for Alzheimer's that I am so on board with that I've joined their company as a volunteer advisor, actually as an employee, like chief scientific officer. I want to see this get forward. But there's a lot of things coming up that I think are going to affect Alzheimer's and other diseases. But in all cases, they can't find the funding. It's like, this is why cancer is not cured. This is why aging isn't cured, because all the ultra high net worth individuals that really want to see their aging get cured and cancers get cured and stuff like that are thinking somebody else is taking care of us. They don't have to get involved. But what I am working on now mostly is trying to get ultra high net worth individuals to start realizing that cancer is not going to get cured, heart disease isn't going to get cured, Alzheimer's isn't going to get cured, and aging isn't going to get cured unless they start providing some funding in a way that is not for quick return on investment. So instead of return on a financial investment, it's got to be return on humanitarian investment. And the only ones that really have enough funding to do that are the ones that are the ultra high net worth individuals. And the famous ultra high net worth individuals, they're all still focused on quick return on investments. I've literally had 20 different ultra high net worth individuals in my conference room where I'm sitting right now, sitting on the opposite side of the table with me. And I don't want to mention names, but you know them all. They insisted on taking control of the company. They typically would want 80% of the company. They also didn't want to invest their own money. They wanted to take out a loan that they can get easily, and then I would make the loan payments. And then they wanted me to do something that focused on quick return on investments so that I could make the loan payments. And so it's got to be the unknown, ultra high net worth individuals that are the most impossible people to reach in the world. They're the ones that have to save the day. They're the ones that have to cure cancer, cure aging, cure heart disease, cure Alzheimer's, because everybody else that has money is only interested in making more money for themselves. And I've learned this better than anybody. I've had over 50 investors. I've worked for many companies that were totally funded by investors. I have many friends that started companies with a dream, and then their companies got sold out from under them. And because the investors were interested only in the dream, but not the dream coming true. And so I'm really, my focus is 100%, well, 80%, 20% on finding go-to-market partners that can bring in royalties for us. And then also the unknown ultra high net worth individuals that really have a passion for doing something to help humanity and themselves.
Incredible. Well, what would be the best way if we have, a listener that is in that category or would like to reach out for investing or anything? What would be the best place to?
It's really hard to do. So I've had 40 in the last year. I've had 40 people that have signed up to work with me to go out and find those ultra high net worth individuals. And in exchange, I was offering a 6% finder's fee that wouldn't be just for the investment, but they would get 6% of all the profits that we make from all the products that get put on the market and things like that. And only one of them is still on board. All the other ones just gave up because it's so hard to reach these people. So it's like you almost have to know somebody who knows somebody, or know somebody yourself that is in that field. And you have got to find a way to go talk to them and explain to them the world's in shambles because everybody is interested in finding a way to make themselves more wealth when they already have wealth. And you got to find those people that have decided they have enough wealth. They don't need more wealth. They know they can't take it with them. They know they're going to be just as susceptible to cancer and heart disease and Alzheimer's and aging as everybody else is. But they really think that everybody else is so well funded that they don't have to even worry about it. They just have to sit back and wait. And sorry to say, they're not going to be very happy with what they see. And a lot of those people and a lot of the famous ultra high net worth individuals that I've talked to have since died, of aging and things like that. But that's what it's got to be really. And
I think there's more and more popularity growing there, and I think you're in a super promising field. I know our interest levels. We get approached pretty often on what we're doing. That's not an avenue we're seeking, but yeah, it's I think the longevity and aging space is a lot more on the kind of forefront of people's minds now, and I think I'd be surprised if things don't change pretty soon on that.
You know what? I have to thank Aubrey de Grey for being the person that pioneered the whole idea of making everybody understand this whole field of aging. He's done a tremendously good job. Organizations like People Unlimited, run by Jim Stroll, and then Liz Parrish of BioViva, Bill Falloon of Life Extension. All these people have just jumped on the bandwagon with Aubrey de Grey to really start promoting the field. And it is getting better and better and better. But it's getting better in a way that's making more and more people invest for a quick return on investments. The high net worth individuals have not jumped in. And yes, you've heard about all these big companies that have been started by really top billionaires, but all of them, they don't understand aging. They hire consultants that are, they know as consultants because of their popularity than their actually skills at doing science. And so they're going on the wrong path. But I hope one of these companies succeed, because my goal is not to have Sierra Sciences succeed. My goal is to have aging cured, even if I end up helping some other company do it. Okay. And I consider all my competitors colleagues working together, trying to help cure my own aging.
Yeah. Well, that's incredible. Fascinating conversation with Dr. Bill Andrews. Thank you so much, Dr. Bill, for being on the show. And wish you the very best. If people want to reach out to you, you got a social media or email?
Actually, I recommend they can go to my website, which is sierrasci.com, SIERRASCI.com. But I don't really keep that up. The best way is to communicate directly with me through my email address, which is bandrews, B as in boy, ANDREWS, at sierrasci, SIERRASCI.com. That is really the best way to communicate with me. If somebody wants to get on board, I will provide them with a signed document showing that they will get 6% of finder's fees, including not just the money that's found, but the profits that generated later. And if somebody is out there in this audience already knows of somebody they can contact me first. Get that signed paper so that when you bring that person to my attention, you're already on board to be getting that stuff. And I love paying these royalties. I've already paid royalties to many, not finder's fees. I pay finder's fees to many people already, and never mind a minute because of the fact that it was such a tremendous benefit to me.
Incredible.
Yeah.
Awesome. Thank you so much for joining us, and you have an amazing rest of your day.
All right,
Have
you
a great
too.
one.
Thanks.
And listeners, if you think this was a fascinating story, please share this with your family and loved ones. Unreasonable Health Podcast on all your podcast apps.